Hello, my DevNation friends. Welcome to another Tech Talk. And today's Tech Talk, we're going to have to be talking about multi-cloud, OpenShift, Kubernetes, and lots of other amazing stuff provided by our amazing presenter, Karan. And I'd like to welcome Karan to the stage. Welcome back to DevNation, Karan. How are you?
Hey Edson, I'm good. How are you?
Yeah, yeah, not bad, not bad. After all, it's a DevNation Tech Talk. And we were
It
having
is, yes.
for the stream and because like CPU and other stuff. And I suppose it's
Yeah,
warm where you are today, isn't it?
it is. It is warm. I'm in India, and the temperature outside is like close to 35 plus. So I think it's warm. So as my Mac is warm, and you can see my CPU is still cranking 70% of utilization, which means yeah, it's hot.
Okay, yeah. And in which city are you
Yeah,
based? Grant?
I'm doing live stream right now from Bhopal, my hometown, and central place of India.
Okay, I think I don't know how to pronounce that. Is it close to another city?
It's simple, Edson. It's Bhopal. So it's
Bhopal.
just Bhopal. Yeah, yes, you did right.
Okay, Bhopal.
Very
Okay, I
close.
can say that. So, yeah, I know people are super excited to see what you have for us. So, I'll just leave the
Mhm.
stage. So, today, live from Bhopal, India, and Cary, North Carolina, welcome to DevNation.
Thank you. All right, so I'll take it from here. So I'll real quick go on video mute, guys, because my system is too hot. So I hope Edson, my video is gone, right? Hopefully. Just for the sake, I'll turn off my
Yes, we can see
video.
you, and you can already show your slides.
Okay, good. Okay, guys. Today I'm going to talk about and show you some live fun demo around microservices or maybe distributed microservices across multiple OpenShift clusters, Azure, AWS, IBM Cloud. So we're going to see lots of distribution in the coming slides. So I'm Karan. I'm part of Developers BU, and I just help my fellow developers, my friends from outside Red Hat, to just get around Red Hat technology, open source projects, so developer evangelism and solution designing, etc. So yeah, I do a lot of blogging as well. So you can follow me on Medium and on LinkedIn as well if you want to. Let's dive into the era and the life of multi-cloud. So let's begin with cloud and let's begin with multi-cloud. So let's try to understand what is multi-cloud. So multi-cloud is, cloud solutions from multiple providers. It could be public provider, it could be private provider, and you choose multiple clouds to deploy your workloads or multiple workloads or tasks across these cloud environments. However, one important distinction between multi-cloud or off multi-cloud is multi-clouds generally is not interconnected. So you have kind of siloed cloud environments, maybe from AWS, Google, Azure, Alibaba, or IBM. So they are not interconnected, right? So if you go by definition, if you go by the book, multi-cloud does not have connectivity between them. You can obviously connect it via the internet, but I'll not consider that as a connectivity. Just for the knowledge, if we talk about a hybrid cloud, generally hybrid cloud has interconnectivity or interoperability between the clouds. So just want to make sure we are clear on the distinction multi-cloud and hybrid cloud. Though hybrid cloud is kind of a different topic at the moment, but so setting the stage, multi-cloud is cloud environment from multiple providers without generally without interconnectivities. So why would one care about multi-cloud? Like, yeah, multi-clouds are great, but why should I care about it? So you can avoid vendor lock-ins. So everyone has heard this proverb like, hey, do not put all your eggs in the same basket because, for all those reasons that you know already. So avoiding vendor lock-ins, you're not locked into a single vendor, single provider, maybe for a single reason, for various reasons. Another good advantage of using multi-cloud architecture is competitive pricing. You can always go and negotiate with the cloud providers of your choice. Like, hey, I'm getting a better price on cloud B. Can you please drop in your price? So there are always at corporate level, at business level, there are always very aggressive cloud pricing wars that goes. So you can also take advantage of that. High availability and resiliency, and flexibility and scalability. So just talking about scalability and flexibility. I mean, at least since I use a lot of AWS and other cloud providers, on multiple times, I have seen those error messages in the cloud provider console, like, hey, sorry, we could not launch your AWS or maybe your GCP or whatever provider you are in a specified region, because we are running out of those instance types that you requested for. So this is meanwhile they would be working under the covers to launch or get resources ready for you. But if you are having multi-cloud, maybe you can spin up resources on a different cloud environment, and if you have the right tooling available, you can deploy your workloads seamlessly on a different cloud provider, and hence have high availability for application and flexibility with scaling. So a couple of reasons for multi-cloud. Okay, so multi-cloud application deployment is complex. I can tell you this because we're going to see this in a few slides. But imagine a world when you need to deploy. You have crafted a nice business application. It's a microservices application, and you are tasked by your friends, by the business owners, like, hey, please deploy my application on multiple clouds at the same time. So it is complex because each cloud provider has their own tooling. They have their own SDKs, their own consoles, their own CLIs, right? So the commands like, hey, launch an instance CLI command on Azure will not work on AWS. Same on IBM, right? So multi-cloud application deployment is complex, and each cloud provider has its own tooling, its own mechanism to launch the resources and give you the compute and the networking and the storage part that you're looking for, right? So what can simplify multi-cloud application deployment? So I mean, Kubernetes, right? We have seen Kubernetes is pretty strong. It's been more than 5 to 7 years. Kubernetes out there, people are deploying this in production. So yes, Kubernetes, which is OpenShift. So by the way, OpenShift is Kubernetes. Kubernetes is OpenShift. So when I use these terms, just assume that I'm talking about the same thing, Kubernetes, right? So OpenShift simplifies the journey to multi-cloud because it provides you the common denominator across all the cloud providers. Your tooling, your processes, your workflows, if you have developed it on OpenShift or Kubernetes on, let's say, cloud provider one, it would remain the same whether you go private cloud OpenShift, public cloud OpenShift, edge OpenShift, or whatever, right? So that is the benefit of using an open technology like Kubernetes to yes, use it for your kind of simplifying your multiple cloud or multi-environment or multi-platform journey, right? So that's how OpenShift and Kubernetes simplifies your journey to multi-cloud. It's easier for you to build your tooling, build your solutions and practices to deploy on cloud A, which will easily go to cloud B and cloud C as you want, because the tooling is constant. However, networking between clusters, networking between Kubernetes clusters, independent Kubernetes clusters is still very complex. Kubernetes cluster on cloud A cannot directly talk to over the same network to a cluster running on AWS or a third private cloud or public cloud environment, right? Because inter-cluster networking is a complex task that has to be simplified if you need to deploy an application or a distributed microservices application across 3 different environments. So how we can solve the networking between multiple Kubernetes clusters, right? So the answer lies in another open source project called as Skupper. So Skupper is an amazing open source project which can help you bridge the gap, or which will help you with interconnectivity between multiple OpenShift or Kubernetes cluster running on any infrastructure, right? So what is Skupper? It's an open source Apache 2.0 license project. It provides you hybrid cloud interconnect, which enables location independent communication. So Kubernetes cluster, which is tied up using Skupper, you can simply deploy the applications as if you are interacting with a local cluster nodes. We're going to see this live in a few more slides. Scupper can help us connect any service running anywhere And maybe it could be you have your Kubernetes cluster running on data centers or other Kubernetes cluster running on AWS, Azure, GKE, whatever. Scupper can tie this up. It's the thread which will tie up all your distributed interconnects or distributed environments or infrastructures, right? It is lightweighted. The beauty of Scupper is that it is lightweighted. It is all in user space and it is developer friendly, which is developer deployable. A developer can simply go and spin up resources needed for application networking or virtual application networking from Scupper. You don't need to go to the admin teams or the people who manages your Kubernetes clusters if there are still any. So Scupper is just developer deployable, and you do not expose any of your services to the public internet. So that's how Scupper, saves traffic. It will kind of make communication secure by not exposing it blindly on the public internet. You also don't need to change your existing application code, right? Which is phenomenal. You can do HTTP REST, gRPC, or messaging, TCP, UDP standard. You just don't need to change any of your application code in order to use Scupper. As a developer, this is a fantastic thing. Scupper simplifies using a secure virtual network. It creates a tunnel between multiple environments, and it gives you a consistent view of your entire cluster. And as I mentioned before, you don't need admin privileges on your Kubernetes cluster. It is 100% developer driven. So in this video, or in this live stream, we're gonna talk about Scupper and actually practically see how Scupper can help you deploy multiple applications. So that's our question, right? How do I deploy multiple, or how do I deploy a microservices application across multiple OpenShift clusters? So that's the task for the day that we're gonna solve in the next few minutes. So it will look like this. We're going to have this e-commerce application composed of multiple microservices: email service, payment service, checkout services, ad services, shipping, currency, product catalog, right? So you got an idea, right? We have Redis as well. We have recommendation service as well. So it's a full-blown e-commerce application, which is microservices, which are each component is a microservice, and we're gonna simulate this. We're gonna deploy this across 3 different environments, which should look like this. So this is going to be our end architecture or end deployable architecture. So we're gonna use Azure, which is ARO, Azure Red Hat OpenShift, on Azure. We're also going to use OSD, which is OpenShift dedicated, running on AWS resources, and we're going to use OpenShift running on IBM clouds. So 3 public cloud providers that we have selected for this demo. On cluster 1, which is our Azure cluster, we're going to deploy 2 microservices and 1 front-end application. Recommendation service and product catalog service would live on Azure cluster. Then on AWS cluster, we're going to deploy 5 services, which is ads, cart, Redis, currency, and checkout service. And on the third cloud, which is IBM cloud, we're going to run email service, payment service, and shipping service. So rewinding it one more time, we're going to deploy these 1, 2, 3, 4, 5, 6, 7, 8, 9 microservices spread across 3 public cloud environments. All of the services are running on top of OpenShift. And as a developer, as a user, you will interact with one of your front-end service, and Scupper, which is the thread which will tie up all the 3 cloud environments running on OpenShift, will allow this distributed microservices to talk to each other. Ideally, just in case for the people who are new to microservices world, ideally, people, you will kind of deploy the entire 9 microservices or the full-blown e-commerce application on a single environment or a single OpenShift cluster. That works fine, not a problem. But this demo is about multi-cloud and distributed deployments of microservices. This is how you can even up-level your architectures, your deployment architectures, by if you have three OpenShift or Kubernetes clustered across any environment. Okay, so I'm excited like these minions at the moment to show you how this looks like. And I'm going to take help from my GitHub repository because there are so many commands that we need to run. And after the live stream, you will get the link to the GitHub repository that I'm going to follow in this demonstration. And by the way, you can follow this at your leisure time, and that should just work. I'm gonna switch to yes, I'm doing good on CPU. Look at this one. Okay, so one more time before I go, I'm gonna show you few more things here. So just for the record, I'm having an Azure portal open up because I'm using Azure. So this is Azure cluster or OpenShift cluster running on Azure, tab 1. Tab 2 is my OpenShift cluster running on AWS, which is OpenShift dedicated, and tab 3 is my OpenShift cluster running on IBM Cloud, right? And the tab 4 here for the record is the GitHub repository, which is again open source. You guys can play around when you want to here. So first we're going to do is we copy this command. We have to do some copy pasting today, and I'll go and clarify I. Okay, so what you see in here is I have three terminal section opened up. As this name says, Azure, AWS, and IBM Cloud. So just make sure you're just following me on here. Okay. Wait a minute. I'm just fixing my. Okay. Now I need this one. Now I need this one. Okay. So what we're gonna do is OC get nodes just to show you three environments running with its own set of nodes in here. Should be coming up. Okay, so this is Azure OpenStack, and this OpenShift, and this is AWS, and this is my IBM Cloud. Okay. So next we're gonna go is we're gonna create a project called as multi-cloud on all the three cloud environments. So we are setting up this demo here. So OC new project multi-cloud, we're gonna create this on all the three environments. So this command should go and run my thing on all the environments. Okay, good. Next up is we're gonna set up a virtual application network on three environments. So we're gonna run these commands sequentially on all our clusters. So Scupper init site name. So we're gonna name our first site as OCP1, OpenShift Container Platform 1. So we are initializing Scupper at the moment on cluster 1. Similarly, we're going to do this for cluster 2 and cluster 3. So initializing Scupper, step 1. Okay, meanwhile, this is running. Okay, Scupper OCP2. And then OCP3 for my IBM Cloud. Okay, so as the command shows, Skupper is now installed on namespace multi-cloud. So as a developer, I'm installing this in my namespace, which is my multi-cloud is my namespace. Okay, so step 2 is creating a token. So we're gonna go and create a token for on our first cloud, OpenShift. This will generate a YAML file which will contain all the tokens needed for the communication between multiple clouds. Similarly, we're going to go and create a second token on the second cloud, AWS. So this will again generate OCP2-token YAML file. And then third, we're gonna kind of link my AWS OCP with my Azure OCP by creating a link. And link will consume the token file created in the first step. So Scupper link OCP1 token is not available. Hold on, let me verify this. It should. Okay, I'm in the wrong directory. Sorry about this. I need to be into this directory because it's generating those YAML files into this directory. Token 1 is here. Okay. which means we also need to generate token 2 because token 2 got generated in a different directory, right? So let me rerun this command here. OCP token 2 from AWS. Okay, token 2 is here. Verifying this again. OCP token 1 and token 2 files are here on the same directory. And we're going to link. We're going to create a link between AWS OCP with Azure OCP. Scupper link create token file. Next, we're going to do same thing on the IBM Cloud, which is kind of connecting IBM Cloud with AWS account and AWS OCP and Azure OCP. So we're not going to run this twice, this command twice with its own unique token file. Init link create token 1 and then create token 2. So at the moment, we are not doing anything with respect to our application. We are just setting up the stage for Skupper. So practically, if you see, we are just running 2 commands or kind of 3 commands to initialize Skupper. So Skupper init, which will initialize Skupper, and then Skupper token create, which will give us the tokens to connect to the clusters, and then cluster link create. So total 3 commands to kind of establish connectivity between the instances. Okay, let me run OC get pods on the 3 machines, 3 environments. Okay, good. So if you see this, we are having Skupper router and Skupper service controller up and running on all the 3 environments, as well as in here, right? So I think we are all set with respect to this part. Up next is we're going to go and verify the link status. So Skupper link status command, we will run this on AWS and see the status of the link. If everything is okay, we should see link is okay. Yeah. So link 1 is active. And similarly, link 1 and link 2 on IBM Cloud. IBM Cloud is getting connected to AWS and Azure. So it has 2 links, right? So links are connected. So we now have a virtual application network established across 3 different OpenShift clusters running on 3 different environments. So step 1 done. So step 2, coming back to our microservices, like, okay, great. Now we're going to deploy as per that last image which I showed you guys, especially this one. Like now next we're going to do is we're going to deploy respective microservices on respective OpenShift environments. Okay, so let's go in here. So we're going to apply some YAML files, and just to give you a glimpse how this looks like, it is standard OpenShift or Kubernetes YAML file. So the first one is microservice architecture deployment OCP1. So we are having a deployment resource, which is my recommendation service, and then standard stuff. We have a deployment for front end. And then we have created some load balancers, and then we have a deployment for product catalog. So this YAML file would be applied on cluster 1. Similarly, if I show you the second YAML file, which is having those 5 microservices, checkout microservice deployment, and then we have cart service deployment, and then we have Redis cart, then what else? Add service. So these are standard Kubernetes deployment files, which we're going to apply on the respective servers environment, so that we can get this kind of an architecture, right? So pretty standard OpenShift. Okay, so let's go and deploy on the first cloud. OC apply -f, and the deployment number 1 is here. Let's do in here OC apply -f MSA deployment 2.yaml on the AWS environment. And let's do it on OC apply -f -f MSA deployment number 3 on the IBM Cloud. So if you observe this output carefully, so we have 2 deployments, and here we have 1, 2, 3, 4, 5 deployments up and running, and then we have 3 more deployments, right? So at this time, the pod should be coming up on our respective environments. So let's verify OC get pods. Okay, great. So we have all the respective microservices apps are coming up on all 3 environments. Nice. Up next is we now need to do some exposing. So exposing the microservices so that they can talk to each other. So we're gonna run a few more Scupper commands to expose our deployments. So I'm gonna show you that shell script before I apply them. So this should look like this. So this is it is kind of a simple shell file, a script file for exposing the deployment. So we're going to use Scupper expose command, which will expose the product service and the recommended service on respective ports, and make sure that they are able to talk to each other, right? So we're going to run this exposing on cloud one. Okay, yep, exposing on cloud one. And then we're gonna do sh expose deployment OCP2, and then do sh expose deployment OCP3 on the IBM cloud. Right? Check the boards in here. So yeah, so we have exposed the required services from the cloud. Okay, one more thing that we should also check, OC get pods on AWS cloud. I think this would be still, yeah, we are getting some errors in the card service. For this, we need to scale down and scale it up once. I still have to figure out the core reason to this. But yeah, for now it works like this. So I'll scale it up and scale it down. Maybe it would be connectivity between multiple cloud. That could be a thing, but that should fix my card pod. Let's see the pods. Okay, so card is coming up, so that's fine. Now, okay, so at this time, our microservices, all those 9 microservices across 3 clouds are up and running. We simply need to go and kind of use the front end, right? So let's grab the endpoint in here. What's the endpoint? Okay, so this is the public IP of my front-end service, and let's do some browsing. And let's do some shopping, right? Go. Okay, online boutique is now up and running. So if you see, this is the holistic e-commerce or boutique application, which is powered by those 9 microservices running on 3 different clouds. The data that you see here is coming up from that, right? So let's do, okay, let me get a watch for my wife, though it will not get delivered. So adding to the cart. So follow me here. So we are calling the cart service. We are calling the payment service. We are calling the recommendation service. So you may also like a hair dryer. Yeah, I think so. Okay, add it to the cart, please. So as I'm interacting with this front-end application, we are literally going and hitting those different microservices on those 3 cloud environments, right? Okay, and also I need a mug. All right, let me do 4 mugs for my family. Okay, so my order book looks good. I have to pay like $180. Okay, let me place the order. So if I click on this, it will go and call out the right microservices, right? Though it will not charge me. And this is my order confirmation. And then, this is my tracking ID. It's all just, made up. But yeah, so you can, if you following me, I'm interacting with a microservice application under the backend using this front end. So it's good. So this is, it works. Now, few more things that you would like to see. We're gonna go and get the Scupper UI. Scupper provides you a nice UI so that you can interact or you can get to know the flow of your traffic. So I'm gonna copy this route in here and show you the Scupper UI as well. I think we also need to get the password. Meanwhile, username is admin, and we need to grab in the password, which is in a secret. and doing a base64 decode to that. Okay, is a command. Okay, so my password without this bracket is this one. Copy and paste in here. So this will let me into the Scupper UI dashboard. Okay, connecting. Alrighty. So this is our services view. So these are our different services that Scupper detected, because remember we did those expose things. So Scupper makes a minute about it, and it also shows us how traffic is flowing between these microservices. If we go and see the deployment tab, it shows you a pretty nice view of your environment. So this is my, let me put it here. Okay, if it's too small for you, let me also try to increase the size. It gives you a nice kind of a, you know, graph here, so that we are not cheating here. We are still literally have three OpenShift clusters. So OCP1 is our first cluster, which is hosting three services, one front end and two backend services. And then on OCP2 we have five more services, add and checkout and Redis and all those services. And on OCP3, which is on IBM Cloud, we have three services. So this is how three services are interacting with each other as we put load from the front end. So as I go and interact with microservice, the traffic will flow between these services, and Scupper will detect it and kind of show you live in this view. So this is how Scupper simplifies inter-cluster networking between your OpenShift clusters or Kubernetes cluster for that sake. And this is how you could kind of distributedly deploy your microservices on three different environments, and Scupper makes it happen. Scupper helps you with interconnectivity between them. So I think this is all I have for the demo here. Before I go, yeah, I'll do the cleanup later on. So this is the GitHub repository. We will provide you in the link to the description of the video below. And yeah, if you're interested to, oh yeah, maybe I can assist those who are new to OpenShift. You can see like OpenShift gives you a nice UI from where you can kind of list in, go into. It's pretty handy, right? Multi-cloud is my project name, multi-cloud. If I go in here, I can see the stats, the CPU memory, or the resource utilization of my namespace. I can also go and see my workload, all the pods which are running on the cluster. I can go and kind of connect to any of the cluster, see the logs. So it's standard OpenShift UI, which provides a great visibility to you as if you're a developer. You can always go and switch to the dev console. Okay, I'll skip it. And similarly, you can see the topology view of your entire cluster or your entire application that is running on here. So it's taking some time. Yep. So look at this one. So we have 5 pods or 5 deployments in here. So I can see nicely in my developer console, which OpenShift provides you. And finally, if you like to play with OpenShift or like free of charge OpenShift, I would really recommend and give you guys this link, developers.redhat.com. You can go in here for all the great resources that our team produces. And you can go and grab a free or kind of claim your free developer sandbox environment free of charge, and just play around with OpenShift, and you can follow these nice tutorial thing which will kind of help you navigate with OpenShift and things, and you can build like cool pizza delivery app on example apps on here. You can also go to the learn.openshift.com or for more interactive videos if you like to. So there are a lot of resources available on the developer portal that we have. So if you've not already checked in, please go and check out. You have lots of free goodies as well with respect to environments. And I think, Edson, this is all I have for the audience to show today.
Awesome. Great demo. We had some nice comments here in the chat, and we have lots of questions for you today. So let's see.
Okay.
First here, yeah, Massimo is asking, how this compare with like he was talking about Scupper, like how this compare with Istio mesh across clusters?
Okay, so I think I'm not played with Istio Mesh. Maybe Arsen, you have. If you have not, yeah, I still have to play with Istio Mesh. So yeah, there's something that I have to investigate. And
Mhm,
thanks for the question. Maybe next time I should do a talk on that.
mhm. Yeah, I think that Scupper allows us to have like this tunnel, so we can have this communication
Mhm.
across different clusters. For example, I never
One thing I can
Istio
go ahead, go
across
ahead. Please continue.
clusters.
Please continue. Yeah.
Yeah, so I don't know if it really applies here, but I'm not sure of this question.
One thing I can also add to this, Adson, is I mean, Scupper is not only limited to Kubernetes, though Istio is kind of a Kubernetes kind of a solution. You could also connect resources on non-Kubernetes environments using Scupper. So for example, a RHEL box. You can configure Scupper on a RHEL machine, like a standalone RHEL machine, a physical or virtual machine, which can also be a part of this virtual application network. So imagine, you have few RHEL machines, boxes on the same network, and then you have your multiple Kubernetes clusters on the same network, and they can talk to each other. So Scupper could also go to that level, right? So it gives you more flexibility in that terms. So yeah, that's the only point I can add to this question at the moment.
Cool. So let's see. Next question from Radical IT. What is the relationship between Scupper and API Gateway?
Oh, they are completely different. So API gateway as the name says, API gateway. All your interactions goes to API gateway first, and then the traffic moves to the right microservices. Scupper is just allows you to create a virtual network among resources. API gateway is restricted to a single Kubernetes or OpenShift cluster. I mean, you can always go and extend that. However, the traffic does not flow under a tunnel kind of a network pipe in API gateway. While in Scupper, all the traffic goes encrypted between the tunnels that it establishes across using those Scupper init commands, right? So it creates a secure tunnel between your resources and let your application talk to each other on an internal network or a tunnel network. While API gateway is more of okay for services, but it's more for a front end to your backend applications.
Okay, and Andrea is asking, which tool is being used to submit commands, the same command on multiple terminals at the same time?
Oh yeah, that's my one of my favorite because I use this almost daily. It's a item two terminal that I'm using. So if you press, it's a shortcut. If you press Command Shift and I, it will activate terminals on or the cursor on all the three terminals, and then you can see, hey, clear. So it's pretty handy command that I use. And also make sure that you press the same command again to kind of back to a single mode. So Control Shift and I, or Command Shift and I on Mac. You will always have different combination for other environments. I think all general tools provide you this facility. An item 2 is specific to Mac, but yeah, Control Shift I is the secret sauce.
Cool, that's a trick I didn't know, and I use iTerm too. So yeah, another
Oh, is it? Oh, nice.
nice tip. And here, let's see, Dosa Rolas is asking, how does Scupper compare to, say, OS Advanced Cluster Management?
OS Advanced Cluster Management, huh? That's a good one. So advanced cluster management, allows you to interact and manage the life cycle of your OpenShift clusters. Yeah, that's it, right? It helps you with life cycle of the entire cluster, not the application running inside them. You can also deploy application through the ACM cluster UI on that. And more or less, ACM cluster managers, it makes your life easy if you have lots of OpenShift clusters, even to the far edge. because we are having customers who are deploying OpenShift on single machines, as you know, single node OpenShifts. And if you have hundreds of these clusters, it's practically very difficult for you to manage. So ACM is kind of, hey, a single pane of UI and a very kind of a user interface which allows you to manage the life cycles of those clusters. While Scupper is very basic, it creates a virtual application networks across those clusters if you want to. So they are very different in terms of application and use cases.
Mhm. Cool. I think that was the last question that we had here in the chat. And Burr is saying that this tip from my term two is the most important thing he learned today. And well, maybe I can tell the same. Hey, it's a very nice tip. Thank you, Karan.
Thanks for joining, Burr. Love to have you.
Yeah. And I think we're done with the questions. So, Karan, I would like to thank you very much again for this amazing presentation and amazing demo. I already shared the link to the GitHub repo, and I told them that the slides will be available shortly after this presentation,
Yeah.
after our marketing team updates the web page on our website.
Yep. And as well as the link to my Git repository, if people are interested to play with. Yeah.
Yeah, I shared on the chat already, so they have
Oh,
it.
fantastic.
Okay. And if you enjoyed this presentation, I hope to see you soon in another DevNation Tech Talk or another DevNation This Show. And Karan, thank you very much again. You're always welcome here at DevNation.
Thanks, Edson, for having me here.
Thank you.
Cheers. Bye.
Bye. Take care.